Do you feel the vibes?
Hello grade 9, this is Mr. Ahmed Samir and a new lesson of unit 1. It is called the polynomial functions. We will divide it into two sessions. Let's today learn what is the meaning of polynomial functions, and we will learn the degree of the polynomial functions, and if we can, we'll study some special polynomial functions. First of all, the definition of the polynomial function. The polynomial function is a function whose rule means images of x, and it consists of one term or more. Again, the definition is a function whose rule means images of x, and the polynomial function consists of one term or more, but under conditions. Number one, the domain and the codomain of the rule of function. We learned it before, the meaning of domain and the codomain of the rule of the function are the set of real numbers, must belongs to the real numbers. Number two, the power of the variable x of any term in the function must be natural number, must belong to n, the set of natural number. Let's understand more with examples. We have three examples here. Number one, f of x equals 7, f of x equals x minus 4, f of x equals x power 2 minus 3x plus 8. Where is the rule here? The rule in the first example is 7. This polynomial function consists of one term is 7. The second example, f of x equals x minus 4. We have two terms here, so this function consists of two terms. Number 3, f of x equals x power 2 minus 3x plus 8. We have now three terms, x power 2, 3x, negative 3x, plus 8. The rule in the first example is 7. The second example, the rule is x minus 4. The rule in the third example is x power 2 minus 3x plus 8. These are the rules of the function. Now, where is the conditions in these examples? Let's see for any example, like the second example here, x minus 4. We can substitute x or replace x by any real number, like 1, negative 1, 3, any real number, and the image of x will be, the image is the codomain, will be real number. Condition number 2, the power of x here is 1, so the power is a natural number. The power here 2, the power here 1, natural number. The power here is what? X power 0. Any number power 0 equals 1, so natural number. So these examples are polynomial functions. Another example, f of x equals root of x plus 8. Now, if we apply the conditions of the polynomial function, we will find that we can't replace x by any negative number. We can't find the result of any negative number under the root. Let's see its domain. We can substitute by any natural number, but we can't replace x by any negative. So we can find the result of the square root of negative. So the domain is the set of natural numbers, not real numbers. Another example. F of x equals 2 over x plus 3. The power of the variable x, the power of the variable x in the denominator is 1. But if we convert it to the numerator, we will change it to x power negative 1. Now, the second condition doesn't satisfy. So, if the function contains in each of its terms root of the variable, or if the variable in the denominator, it is not polynomial function. The second point in our lesson today, the degree of the polynomial function. We learned before the degree of any equation is the highest power of the variable in the equation. By the same way, the degree of the polynomial function is the highest power of the variable in the rule. Let's see an example. F of x equals 3x plus 7. The rule here is 3x plus 7. F of x equals 2x power 2 plus x minus 20. F of x equals x cube x power 3 plus x power 2 plus 4. Finally, f of x equals 6. In the first example, the highest power of the variable, where is the variable here, is x. The power of x here is 1. So, the degree of this function is the first. This function is the first degree. And we can name it, we can call it, we can denote it by linear function. Number 2, 2x power 2, the rule, 2x power 2 plus x minus 20. We have two variables, x power 2 and x. The highest power here is 2. So this polynomial function of second degree, we can denote it by quadratic function. Again, the first degree is called linear function, the second degree is called quadratic function. Number 3, we have two variables, but not different variables, but different in the powers. X power 3 plus x power 2, the highest power is 3. So this function of third degree, and it is called cubic function. The last one, f of x equals 6 without any variable. So we can consider x power 0, 6x power 0, and x power 0 equals 1. So we can write it. So f of x equals 6 of 0 degree. And this function, it is called constant function. If the function without any variable like this, called constant function. First degree linear, second degree quadratic, third degree cubic, and 0 degree constant. Another example, f of x equals the rule of it, 2x power 2 minus 5x plus 2. Mention the degree of f. The greatest or the highest power here is 2. So this function of second degree, it is called what? Quadratic function. Number 2, prove that f of 2 equals f of half. What is the meaning f of 2? F of 2, if we replace x by 2 equals the result if we replace x by a half. Let's see. Firstly, f of 2, we will replace x by 2. 2 times x power 2, we must write it in a brackets and the power out of it. 2 times 2 power 2 minus 5x means 5 times 2 plus 2 equals 2 power 2 4. 2 times 4 equals 8. 8 minus 10 equals negative 2 plus 2 equals 0. F of half equals 2 times half power 2 minus 5 times half plus 2 equals a half power 2 equals quarter minus 5 over 2 plus 2 equals 0. So if we substitute by 2 equals substitution by half. Let's solve another example. Choose the correct answer. Number 1, the function f of x equals 6x power 7 plus 2x power 5 minus 4x plus 1 is a polynomial function of what degree? The greatest power here, the highest power is 7, so the function of 7th degree. Number 2, 2x minus 3x power 4, the highest power here is 4, so the degree is 4th degree. The function x minus 5 all power 3, if the bracket power 3, so the function of 3rd degree. F of x equals x times x minus 2x power 2. If we multiply x in this bracket will be x times x power 2 minus x times 2x power 2 equals minus 2x power 3, so the highest power will be 3, so the polynomial function of the 3rd degree. Number 5, x power 2 times x minus 3 all power 2. If we put this bracket in the standard form will be x power 2, the greatest power for the bracket only, x power 2 times x power 2 equals x power 4, so the highest power in this function will be x power 4, so the polynomial of 4th degree. Number 6, f of x equals x cube x power 3 minus 1. So f of 1, what is the meaning of f of 1? We will replace each x in the function by 1. So 1 power 3, 1 power anything equals 1. 1 power 3 equals 1. 1 minus 1 will be 0. So f of 1 equals 0. The last one, f of x equals x power 2 minus x plus 3. Then f of 3, we will replace x by 3. F of 100, we will replace x by 100. So 3 power 2 equals 9. 9 minus 3 equals 6. 6 plus 3 will be 9. Now the last point in our session, the linear function. The linear function is a polynomial function of the 1st degree, and the standard form of it is f of x equals ax plus b. X is a variable, a and b are numbers. A is a coefficient for x and b is a constant. Examples: f of x equals x plus 2. A in this example is 1 and B 2. Another example, f of x equals 3x minus 5. A here is 3 and B negative 5, not 5, negative 5. Here f of x equals 6 minus third x. A is negative third. A here is negative third and B is 6. An example, represent graphically f of x equals 3x minus 3. Now we will study the linear function and representation of it. First of all, we will determine three values for x and we will get the corresponding values of f of x, or we will say y. F of x is y, so we will choose three values for x like 1, 2, 0, and we will get the corresponding values for f of x or y. Let's see. The first value 0, so f of 0 equals 3 times 0, 3x. 3 times 0 minus 3 equals negative 3. We have two values, 0 and negative 3. 0 is x and negative 3 is y, or f of x. So we can form ordered pair 0 and negative 3. The second value 1, if we replace x by 1, f of 1 equals 3 times 1 minus 3 equals 0. X is 1, y is 0. F of anything, the number here is x, the number here is x, and the result is y, or f of x. So we can form the ordered pair 1 and 0. Next, the third value is 2. We substituted by 0, 1 and 2. 3 times 2, 6, minus 3 is 3. Now we can form ordered pair 2 and 3. This is the first step. We will determine three values and we will get the corresponding values for it to form three ordered pairs. Step number 2, we will record these results in a table like this. Horizontal table consists of 4 columns, x and f of x or y, 0 and the corresponding of it negative 3, 1 and the corresponding value of it 0, and 2 with 3. Step number 3, we will represent or graph it by the Cartesian lattice like this. Now we will locate these 3 points which represents the 3 ordered pairs in the Cartesian plane and draw a straight line like this. The first ordered pair 0 and negative 3, the second 1 and 0, the third 2 and 3, and we will connect them by a straight line like this. This graphical representation of this function, this is straight line. Now another question in this example, the point of intersection with y-axis. We have 2 points in this example, the point of intersection with y-axis and the point of intersection with x-axis. Firstly, the point of intersection with y-axis equals 0 and b. Always the first projection is 0 and the second is b. B here is negative 3. In this example, B is negative 3. So the point of intersection with y-axis is 0 and negative 3. Secondly, the point of intersection with x-axis, the rule of it, negative b over a, negative b over a, and 0. B is negative 3. Negative of negative 3 is 3. 3 over 3 equals 1. So the point of intersection with x-axis is 1 and 0. We finished our session today. I hope you benefited from this session and wait for me the next session, inshallah.